Okay, so this is a new thing that we're doing. Rather than just walking and holding a board and seeing what happens to velocity time graphs and position time graphs, now we're going to move over to using these kinetics tracks. They're very expensive. Please be very careful of them. These carts, please don't put them on the table, on their wheels. Only put them on the wheels on the track. Okay? They got very sensitive little ball bearings in them. I do have to change the wheels every now and again, but if we're careful with them, when you do that, they should just run. Okay? If they stop very quickly, it means there's a problem and you should tell me. Because we're trying to look at a situation where we have a steady speed, we want to make sure there's not anything interfering with that. The biggest thing that could interfere with having a steady speed is to have this thing on a slope. And we use a spirit level. It has two lines and it has a bubble. If you look at it from the top here, you can actually look down on top of it, which is more accurate. Don't ever cock your head like that to see whether it's level. Always go down, right? So that you're looking at it straight on, and that way you'll get the most accurate reading. The bubble is slightly less far from one end to the other, is slightly less than the distance between the two black lines. So initially what you do is you just try to get it between the two black lines, but then to get it finely adjusted, what you're looking to do is get the gap between the end of the bubble and the black line at each end to be exactly the same. It's a multi-step process. You first of all level it this way, the long way. Then what you do is you come up to where the legs are, and the legs should typically be 1/3 in, right, at each end, so they're sort of supporting as much as they can. And then you look at it on this side as well, and you've got to level those feet. You then come down here, and you do the same thing. You're trying to get it level by adjusting these 2 feet. Doing that, if you're not careful, you're going to have messed up this level. In fact, that's usually the case. It's a trial and error thing. So you're going to fix this one, you do this one, you do this one, you come back. And then you get it right again, and then you come back here, and back here, right? Typically, it should take you 2 sequences. It might take 3 to get this thing perfectly level. Once it's level, let me show you something about these feet. These feet are actually held in, and notice that one is on one side and one is on the other so that these end stops can move past them. It's held in with a square nut. The square nut fits in the square channel. But you'll also notice when you look at these feet that there is an extra knurled knob here. Do you see that? Knurled means it's got little indentations in it. That is a lock nut. So what you can do, I'm just showing you this off the table, but you're going to have to do it with it on the machine, on the track. You now screw that up against the bottom of the leg. It's now, or should be, now locked and not moving, right? If I take the lock nut off this one, you should be able to see, right? You should be able to see that this one's moving, that one's not. That's why the whole thing wobbles. So use the lock nut to stabilize it once you've leveled it, okay? And then double check your levels again. One other thing, if you don't want to have a lot of noise, you really need to clean your track. Dirt gets in this, especially this small track here, and sometimes there's particles that will actually make those wheels jump. So you'll find these towel things around the place. Just stick a little bit of Windex or something on it, and what you've got to do is push it into the small the small track, move it all the way along, and you can see, right, it's actually quite dirty. It picked up quite a bit of dirt, dirt and little particles. That will not help you with your experiment. Same thing on this one. When you're setting these up, please always put the track on this side of the lab bench. Put your computers on that side. Don't put the top of the computer so close to the track, and it actually doesn't have to be that close. I mean, even that close is too close, depending on where the ultrasonic distance sensor is, because the beam from the sensor comes out very broad. That will upset your experiments. Make sure that the ultrasonic distance sensor is set to Kinetics card rather than walking. And then what you're going to do, obviously this one is not leveled, but you'll put this on here so it's perpendicular, and then you're either going to be pushing it away or pushing it towards. Remember, you can't bring or start measuring anything that's closer than 20 centimeters from these. They're not designed to be measuring closer than 20 centimeters. So make a gap. You've got a ruler on the side here. This one's at about 30 centimeters, the front of the thing, so I don't want it to be any closer than 50. This particular item here is usually used for holding a force sensor. This one's on as if a force sensor was going to go in it. In order to change this, you're going to need a Phillips head screwdriver, which you can get from my toolkit over here. Screwdriver from my toolkit. I'm going to take this out. I'm also going to show you where we put the screw when this thing is not on the cart. If you look at the holes here, they are in fact threaded. So the threaded hole is purely for the purpose of keeping this screw stored while it's in your parts box that you have. All right, so that's how it's stored. Please store it back that way when you're finished. If you're going to use it for a force sensor, it does need to be this way.